Assalamualaikum warahmatullahi wabarakatuh to our lecturer, Dr. Azima. I am Siti binti Yusof. With my partner, Siti Hajar Najihah binti Romali, we will be presenting our findings on the article titled Highly Fluorescent Carbon Dots Derived from Mangifera indica Leaves for Selective Detection of Metal Ions. So this is the front page of our article that was published in the journal called Science of the Total Environment. For the introduction, some background knowledge relating to this study, particularly semiconductor quantum dots. It is used in optoelectronics as a detector, sensor, or bioimaging devices, and it can be made from lead, silicon, or silver. Then studies have attempted to replace the previous materials to carbon because the elements such as lead may risk harming the environment. The new carbon quantum dots can be made through breaking down the bulk source, the carbon source, into nanoparticles or through the nucleation process from the precursors. Hence, this article attempts to prepare the carbon quantum dots, which is the CQDs, from the leaves of Mangifera indica or mango trees, and to apply these CQDs for the selective detection of iron 2 plus ions in real sample.
Synthesis of mango indica leaf derived CQDs. Firstly, the leaves were cleaned by washing with water and then chopped. Secondly, the chopped leaves were heated at 300 degrees Celsius for 3 hours to completely evaporate the moisture. Next, the dried leaves were pulverized. Then 4 grams of the powdered leaves and 5 ml of hydrogen peroxide were added into 200 ml of deionized water, and the solution was stirred at ambient temperature for 12 hours. And the solution was then vacuum filtered to remove any precipitates and to obtain the purified CQDs. And next, the pH-dependent photoluminescence sensitivity of the synthesized CQDs was observed on a photoluminescence spectrophotometer. The detection of metal ions was conducted to evaluate the metal selectivity of synthesized CQD. It was performed under different experimental conditions like temperature, stirring speed, and retention time. It was observed that the maximum quenching in the PL intensity was observed with iron 2 plus ions. For the instrumentation, 4 instruments were used, which are UV spectrophotometer, FTIR photospectrometer, and also high-resolution transmission electron microscope. Results and discussion will be divided into 3 parts. The first one is the physical and chemical properties of CQDs. An optical absorption spectrum of the CQD was recorded from 200 nanometer to 800 nanometer as shown in figure 1A. It showed a broad peak around 230 nanometer, which likely reflects the p-p star transition in the conjugated C double bond C domain of the carbon core state. Figure 1B, on the other hand, showed a high-intensity emission peak around 525 nanometer. This massive blue light emission was likely due to the differences in particle size distribution and light radiative state present in the synthesized CQD. Next, figure 1C illustrates the PL emission spectra of CQDs at different excitation wavelength. It could be concluded that the PL emission spectra of CQDs depended sensitively on excitation wavelength, as redshift in peak intensity was observed. Figure 1D, on the other hand, shows the FTIR spectra of CQD. It can be observed that the stretching vibration of carboxylic acid and hydroxyl functional groups are present. In addition, the vibration mode of CH bond, C double bond O, and asymmetric stretching vibration of double bond CH bond. The vibration of C-C double bonds, stretching vibration of C-O-O bonds, and the bending vibrations of amine bonds are also present. Next is the pH dependence of CQD's PL emissions. To explore the pH effect on sensing potential of CQD, PL intensity for the CQDs was monitored at different pH values, which are 1, 3, 5, 7, 9, and 11. As shown in the figure, under strong acidic conditions or under strong alkaline conditions, the fluorescence intensity peaks were weak. Under strong acidic conditions, the CQD surface was favorably occupied with carboxylic acid groups. In contrast, under strong basic conditions, the amine functionality becomes dominant on the CQD surface. The highest fluorescence intensity was observed at pH 7. Therefore, the whole sensing platform was adjusted to a neutral pH value for optimum detection of iron 2 plus ions.
The next part on the effects of iron 2 plus ions on the photoluminescence spectra of the CQDs. So here the CQDs will be evaluated on their performance using Fe2 plus that is present in water and real sample. The first aspect is on its selectivity. We want to know whether the CQDs is responsive to any metal ions or is it selective only to the presence of Fe2 plus ions only. So based on the photoluminescence spectra, there is a significant decrease in intensity for Fe2 plus only. This means that CQD can be used for qualitative detection for the presence of this ion. Not only that, it can also be used quantitatively to determine the concentration. This was confirmed by the linear relationship between the concentration of Fe2 plus ions and the log of the PL intensity. Also, the limit of detection or LOD for the synthesized CPDs was found to be 0.622 ppm, which is much more sensitive than carbon dots made from dopamine and plants. Lastly, the CQDs are then tested for Fe2 plus content in Livogen tablet. So this tablet is a supplement containing iron in the form of ferrous fumarate, usually used for treatment of anemia or any conditions related to iron deficiency. And based on our result, it was proven to be effective as the fluorescence intensity decreases as the concentration increases. Briefly on the sensing mechanism, presence of the metal ions such as Fa2 plus, depicted as yellow and blue circles in the diagram, will cause a non-radiative relaxation of the CQD's electron where less photons are released. This results in a decrease in intensity of the emitted light, or we can also call it as photoluminescence quenching. To summarize, carbon quantum dots or CQDs were able to be synthesized from Mangifera indica leaves through a process that involves heating but without any chemical treatments, and it has a great potential in quantitative and qualitative analysis of Fe2 plus ions in comparison to the previously synthesized quantum dots. From other studies, these CQDs are lower in cost, non-toxic, selective and sensitive, and have a greater long-term stability. So that is all from our group. Thank you for your attention.